Good afternoon, everyone. My name is Santosh, and I will be taking today's class again. Okay, so this is probability and stats class, right?
Yes, sir.
Okay. So in the last class, we just introduced what is estimator, okay, and what is unbiased estimator. So we were discussing that unbiased estimator. Okay. So anyone, please tell the definition of unbiased estimator. So in the last class we were discussing this, and I have given you two questions also. So I solved them, but last part I did in a hurry because time was already past. Yeah. So anyone, please tell me the definition of unbiased estimator. What is unbiased estimator? So no one remember what is unbiased estimator? There are 49 people. Yes, anyone? Tell me what is unbiased estimator. So we discussed in last class. So I hope you were there, and if not, then you can read from book.
So the
Hmm. बोलो.
of a parametric.
Arey, you can use book, notebook, Google, anything. Just I'm asking you what is unbiased estimator. So you tell me answer. You can use anything. Okay, I'm not restricting you to use. Like you can tell from your notebook, from your book, from the Google, anywhere. But you should know. So tell me.
So any function of a random variable to estimate the known value.
I think you are trying to tell, but you are not audible well. So actually, I'm not able to hear you clearly. So I don't know what is the problem. Yeah, what about others? So why do you attend class then? If you don't remember things, and in the whole last, I think 1 hour, the whole class was based on that only. In fact, suppose it was 1 hour, then half an hour I spend on unbiased estimator only. There's just one line definition. Mathematically, you have to tell what is meaning of unbiased estimator. What is definition of unbiased estimator? Yes, anyone else? Please tell me
So,
what is. Yes.
sir, if expectation of theta cap equal to theta,
Yes, so why do you take so much time? It's just one line thing, expectation of theta cap is theta, that is unbiased. So they're asking from last 5 minutes. Just definition, 10-second definition. Yes, expectation of theta cap is equal to theta. Then we call theta cap as the unbiased estimator of theta. So why do you take more time? Because many of you know. Okay. Why don't you respond quickly? So expectation of theta cap is theta. So we call theta cap as unbiased estimator of theta. Okay. And theta cap is an estimator, or you can say statistics. Statistics. Okay, so we discussed these things in last class. But I will continue with that example we were giving. So example was you had a sample like let x1, x2, xn be a random sample of size n, okay, from a population with mean mu and variance sigma square. So then the first point was prove that. So I'm writing prove that, okay. So it there I was asking you to check. So first point was prove that x bar is unbiased estimator of mu, that I solved in last class, okay. A second, s square is unbiased estimator of sigma square. So that I did, but quickly, you know, so I was not able to make you understand. So that was something was wrong there. So I will do it now again. So before that, anyone tell me what is meaning of x bar and what is meaning of s square? So what is x bar in terms of that x1, x2, xn? How do you define x bar? So it is not one way communication, right? You are in the live class. No, it is not the recorded meeting. It is not the YouTube videos. Only you will see. Okay. So you have to respond. Otherwise, I will stop taking classes right now. I will not continue teaching. Okay. So I will mark all of you absent right here. So you have to respond currently because you are attending live classes. Otherwise, why university is arranging the live classes? They will provide you the link of the YouTube link somewhere. Just go and watch. Yeah, tell me what is meaning of X bar?
So it is the mean.
So how do you define what is meaning of mean? And again, I'm saying you can use your notebook, book, Google, something, anything, but you have to be here. You have to respond. Okay, you have to learn.
So summation of x sub I divided by n, where n is the number of samples taken.
All right, number of random variables, yes, or size of the sample size. Yeah, fine, thank you. And what is S square?
So summation of x sub I minus x bar whole square divided by n minus 1.
Yes, yes. So it is 1 upon n minus 1 and summation xi minus x bar whole square I from 1 to n. Okay, so I proved this in last class. This is very easy. So second part I will do now. Then we'll continue. So the second thing, S square is the unbiased estimator of sigma square. So means we have to prove indirectly expectation of S square is sigma square. This we have to prove. So we'll start from here. So we'll start with. So we have to prove expectation of S square is sigma square. So let's start solving this. S square is 1 upon n minus 1 summation xi minus x bar whole square. Okay. Sorry. Whole square already there. So 1 to n. Using the property of expectation, you can take 1 upon n minus 1 outside. Now expectation. summation xi minus x bar whole square. Okay, I from 1 to n. Now what do? You just open this square. Okay, so you just open it. So 1 upon n minus 1 expectation. Now just open this summation. First open this square, then summation. So a minus b whole square, you all know, a square plus b square minus 2ab. So you can write anything first. So 2ab. Okay, this I just opened square. And now continue. So 1 upon n minus 1. Expectation is outside and summation is inside. So you can apply summation now. So summation will be, this is summation xi square I from 1 to n. Now there is no I here. Here there is no I. So this will be added n time. So this will become nx bar square. Okay, just remember why there is no I. So summation is over I from 1 to n. So for example, summation of 3 and I from 1 to n. So that will be 3n, because 3 will be added n time. 3 plus 3 plus 3 n time. Okay, so same like that here. X bar is a constant, you know, for I. So it is free from I here. So that's why we added in time. Again here, minus 2x bar you can take here, and summation will be applied over I 1 to n. So there is no I here, so it came outside, and summation applied over the term involving I. Okay, so I just opened summation to each term. Okay, and now I will apply expected. So before that, you all know x bar is 1 upon n summation xi. If you do cross multiplication, then what you will understand, nx bar is equal to summation xi. Okay, so I will use it here. So instead of this summation xi, I can write nx bar. Okay, so I can write nx bar. So what will happen? So it will be simplified to, so expectation is outside, summation xi square I from 1 to n plus n x bar square minus 2x bar is already there, and summation xi is n x bar. Okay, and now continue. So just in place of summation xi, I have taken n x bar, and just keep doing. So 1 upon n minus 1 expectation. Now 1 minute, 1 minute, I did something wrong here. Bracket is not here because we have already taken summation over each term. Okay, so this bracket is not required now, because this we have already opened, na? We used this bracket already, we have opened it, and summation we applied over each term. So that's why, yeah. So this summation is over this term only, not to other term. Okay, now what will I do? Okay, let me just write once more. Summation xi square I from 1 to n and plus n x bar square. Here is, if you multiply, minus 2n x bar square. This is minus 2n x bar square. So 1 upon n minus 1 expectation summation xi square nx bar square minus 2n x bar square. So in the negative there are two coefficient here. Here is 1. Okay, so 1 minus 2 is minus 1, so minus n x bar square will be here. So this I simplified, just I simplified the this part, just I simplified this part. Okay, expectation is still outside. Now we'll open expectation. So now you apply expectation. Okay, so let's apply expectation. So 1 upon n minus 1 expectation. So I'm opening expectation for first term. So summation xi square I from 1 to n minus expectation. This is also a random variable. Okay, x bar. So that's why you have to apply here. So if you wish, you can take n outside, but x bar square will be there. Okay, so what I did, just we applied expectation over both term. Now I need summation xi square. So summation can be taken outside, so you may write it like 1 upon n minus 1, and summation you may take outside, and expectation you can take inside by using property of expectation, I from 1 to n. So what I did, summation outside, expectation. Like for example, expectation of x1 square plus x2 square. So you can write it expectation of x1 square plus expectation of x2 square. Just I did the same thing, okay, in general. So x1 square to xn square. So you can apply expectation over each term. So that is being done here. Okay. So now minus n time expectation of x bar square. And now actually expectation of x bar we have already known. So here what I need, the thing I need I will write here. So you know one thing, expectation of x bar is mu only. Okay, so mu is the same mean from the population. This mu is the mean. Okay, so each x1 x2 xn has mean mu, so that will be same as same mean for x bar also. But now I want variance, so variance of x bar. So can anyone tell me the formula for variance of x bar? You may read this if you need. So corresponding to this I'm talking. So x1 x2 xn, so x1 x2 xn be a random sample of size n from a population with mean mu and variance sigma square. So in that sample, what is the, so as I told you already, expectation of x bar is mu, that I proved in last class. Variance of x bar, can anyone tell? This I think you have already done, maybe. I don't know, but if you have done, can you tell me? Because I have not taught you already. Na? I'm teaching you from just last two class. So last one class, this is the second class today. So do you know or not? Anyone can tell me, those who attend regularly class. Have you done this or not? Okay, for I will write this. So variance of x bar is sigma square upon n. Okay, so variance of x bar is sigma square upon n. But actually, I need here what? I don't need variance. I need some each xi square, expectation of xi square, expectation of x bar square. Okay. So this is I'm doing for x bar. So variance of x bar. So definition of variance, I think you know. Definition of variance is, it is expectation of x bar whole square minus expectation of x bar and its square. This is equal to sigma square by n. I'm just continuing this line, last line. This implies this. And now I need this thing. So I will keep it here in left side only, and I will send this term to right side. So sigma square by n already plus an expectation of x bar, we know it's a mu. So it will become mu square. So I got this term, that will be used here, that will be used here. But I also need expectation of each. So I got this term, but I also need this one. So in a similar way we can do, since we know that each xi has mean mu, and each xi has variance sigma square, that is given you in the question. Okay, so each xi has variance sigma square. So each xi has variance sigma square, so you focus here. So again, definition of variance, xi square minus e of xi whole square, and that is sigma square. So from here, expectation of xi square if you find, So sigma square plus this negative term will come to right side and become positive term. Expectation of each xi is mu only, so that is mu square. So this I need also, so I got it this also. Now I will put it in left side. Okay, so just let us replace it. So now replace here. So 1 upon n minus 1, it was summation I from 1 to n. And what is the expectation of xi square? So I got it sigma square plus mu square. Okay, minus n time, what is expectation of x bar square? So x bar square I got this sigma square upon n plus mu square. Okay, this thing. And now just let us simplify it. So 1 upon n minus 1, again you can see this is free of I, so just it will be n times sigma square plus mu square. Just n time, it is free from I, so I is from 1 to n, so just you will add this same thing into n times, minus, and you multiply it inside bracket. So when you multiply it will become n, n will cancel, so it will first give you sigma square only, right? Sigma square minus n mu square. Okay, and you open first bracket now. So open first bracket, 1 upon n minus 1, open first term here. So n sigma square plus n mu square minus sigma square minus n mu square. So this minus term plus term get cancelled, and now 1 upon n minus 1. From here you can take common, so n minus 1 sigma square, and you just cancel this n minus 1 n minus 1 and you get sigma square. So what I proved here, so I started with here expectation of s square. So I started with here, and after doing lot of calculations, at the end we got this sigma square. Okay, so you will find this in your book also. So different book had different approach, but you can do one way which you understand better. Okay, so there what I proved expectation of s square is sigma square, and that's why we call s square is unbiased estimator of sigma square. Okay, so this is the proof, you know, we left in last class, so that we completed. Now the next term is from the book. So next part, so we are doing 9 chapter in the book. Okay, so you have a reference book, so we are doing 9 chapter. So now here they are discussing variance of point estimators. Variance of point estimators. So like suppose you have a two unbiased estimator. Okay, so suppose theta 1 cap and theta 2 cap. Okay, so these are two unbiased estimator. So two unbiased estimator means that is expectation of theta 1 cap will also be theta. So unbiased estimator of theta, you say of parameter, so parameter is theta, of theta. Okay, so means that this is the meaning of this line. And now, so actually we want to choose the estimator which is more efficient, or we call it relatively efficient. So which will be more efficient? So it will be decided by the variance. If both have the same expectation, means both are unbiased. So now we have to choose one which is better, or better in the sense which is more efficient. So how we'll define this efficiency? So we defined it in terms of variance. So how we define? So like we call theta 1 cap is more efficient or relatively efficient. This is also relatively efficient than theta 2. Okay, theta 2 cap. Okay, so theta 1 cap is one estimator, unbiased estimator. We call it more efficient than theta 2 cap, that is also unbiased, if variance of theta 1 cap will be less than variance of theta 2 cap. So like if you have two unbiased estimator, so the estimator which will have less variance will be more efficient. Okay, unbiased estimators which have less variance, है ना, least variance you can say, so that are most efficient, you can say in that sense. Okay, so variance is less, so it is more efficient. Got it? So variance, you can remember like variance less equivalent to more efficient. Okay, so this is the, okay, so you can also say that you may write like, so in the collection of all unbiased estimators, okay, in the collection of all unbiased estimators of parameter theta, we call parameter theta. So in the collection of all unbiased estimators of parameter theta, the one with smallest variance, the one with a smallest variance, okay, the one with smallest variance is called, okay, so is called the most efficient estimator of theta. Okay, so most efficient will have smallest variance. So if you have all unbiased estimators, so you will select one with the smallest variance and that will be the most efficient. Okay, so for a quick example, if I write one like, for example, if I say you, suppose n is 5, n 5 is sample size 5, you have 5 like x1 x2 x3 x4 x5. Okay, they are from some population with variance. So this is a sample actually. Okay, call, so this is a random sample, a random sample from a population with mean mu and variance sigma square. Okay, so let me define 2 like t1, or instead of t1 let me write theta 1. So theta 1 cap, suppose I write 1 by 2 x1 plus x5. ठीक है, and theta 2 cap I defined 1 by 5 x1 plus x2 plus x3, okay, plus x4 plus x5. Okay, now what I want, so which one is more efficient? So I will, so first you will check whether both are unbiased or not. So if you find expectation of theta 1 cap, so I'm direct finding half as it is, x1 का expectation होगा mu, because sample has mean mu and x5 has mean mu, so mu plus, so it will give you mu only. If you find expectation of theta 2 cap, So outside is 1 by 5. So 1 by 5 you keep as it is. X1 has mean mu, and they are samples. So sample are IID. So mu plus so 5 time. So 5 mu over 5 it is mu. So means both are unbiased. So here you can check theta 1 and theta 2 both are unbiased. So theta 1 is unbiased and theta 2 is also unbiased. Now you have to check which one is more efficient. So can you do? And can you tell me which one? Okay, sigma square if you want, I may give you. But okay, you try and tell me which one will be more efficient. Out of these two estimator, what do you think? Which one will be more efficient? So expectation I found. Now you check whether which have less variance. Out of these theta 1, theta 2, which estimator will have less variance?
The last one, the second one,
Why?
because the number of elements are five, for which it will be divided with five, so the variance will be decreasing.
Okay, but you have to give logic using definition. So definition says the one which will have lesser variance will be more efficient. So we'll find variance of both. So the logic just sort of give you find the variance of both. So variance of theta one cap. Okay, wait. So like I'm finding variance here. So when you apply variance and here is half x1 plus x5, that is your theta 1. So property of variance is when you take a constant outside that variance, so it will become square. So 1 by 2 will come outside and it will become 1 by 4, you know? So when you take some constant outside the variance, so it will become a square. So 1 by 2, then you apply variance of x1 plus x5. Okay, so what I did, just when you take half outside it becomes square, and now equal to 1 by 4 as it is. Variance here is sigma square. So variance you can directly open it because both are independent. So variance x1 plus variance of x5, sigma square, so it becomes 2 sigma square by 4, so that is sigma square by 2. Now variance of theta 2 cap. Okay, just I'm finding manually, but directly you can do also. This is nothing but this is x bar theta 10 x bar over 5 term, but I'm doing manually. So when we apply variance 1 by 5 x1 plus x2 plus x3 plus x4 plus x5, so now what will happen? uh, 1 by 5 will come outside after being square, so 1 by 25. Okay, then variance of x1 sigma square, variance of x2 sigma square, sigma square, sigma square, and sigma square. So 5 sigma square upon 25, so sigma square by 5. Okay, now you have to compare. So which variance is smaller? So tell me which one is smaller, sigma square by 2 or sigma square by 5?
So sigma square by five.
Yes, so since sigma square by 5 is less than sigma square by 2, means variance of theta 2 cap is less than variance of theta 1 cap. Therefore theta 2 cap is more efficient. Okay, so that is the example for that term. So if you have many estimators, we have to check which one has least variance, that will be most efficient. Okay, uh, so you may understand why that figure also, like sometimes you have suppose theta is here, okay, and you draw a graph of that estimator, okay. So distribution of that estimator, you say. So suppose one is like this. So my intention here is to take this is theta, and one may be like that. So suppose this is theta 1 cap. Okay, so here in terms of that, if I say, so this is theta 1 cap and this is theta 2 cap. Okay, so distribution, sampling distribution, okay, for different estimator of theta, I say. So see, what I tried, both are unbiased. Unbiased means both have mean at theta. Both have mean theta. Both have mean theta, the both are unbiased. Now you want to see from figure which one is more efficient. So you will see the variance. So they, this is the variance, how they are varying. And for the first theta 2 cap, theta 2 cap I'm talking, and this is the variance for the other. So which one varies more? Theta 1 cap, okay. And which one vary less? So theta 2 cap. So by here you can see, or you can say, like in theta 2 cap, the distribution is likely close to be theta, okay. So here from the graph you can check simply that theta 2 cap is more efficient, okay. Why? Because their variance is less. So variance of theta 2 cap is less, that's why, okay. So unbiased, first of all you will check unbiased. Unbiased means the mean should be theta estimator, and then if mean is theta, then you will check the variance, how they vary. Okay, so we discussed in the last class we discussed unbiased estimator, and I continued today that only. And then we discussed variance property. So if two estimators are unbiased, then which one will be more efficient? So the one which has less variance. So we are discussing estimation. So these were point estimation. Now actually I'm following the following book. So in book, next is interval estimation. Okay, so in the book you have interval estimation. So actually in point estimation what happens, you estimate that parameter by a single estimator, okay, or statistics. That may not be accurate, you know. So to increase the accuracy, okay, so what we do, so instead of taking point estimation or point estimate, we'll take actually interval estimate. So like you may say that there are many situations in which it is preferable to determine an interval within which we would expect to find the value of the parameter. So like if you can guess or tell an interval, that you can say, okay, the estimate value of that parameter theta will belong to that. So that will be called interval estimation, okay. Okay, so first let me write the definition. And so what is meaning of that? So let me write the definition, to be clear. So you can, So actually, different intervals will have different possibilities. For example, check. Suppose mu, uh, by the point estimation, suppose you approximated mu as 1. So interval, someone may give you interval like, okay, it may like 0.9 to 1.1. Some may give, okay, it will be 0 to 2. And some may give, no, it is minus 1 to 3. So what happens? The size here is very less. Here is more size is length of the interval. So we actually try to find the length of the interval according to demand. So like what they want. Okay. So the probability, the length is small here. So it depends on the situation. Okay. So like it will give you like find an interval in which there are 95% chance of that estimated value of the parameter will be in that interval. So for example, let me first write the definition, then I will explain. Okay. So like from the sampling distribution, we will be able to find L and U. So let L and U are two estimators. Okay. So that is just a statistics. So you may not write two statistics you can. So this is a function of random variable free of parameter. Two statistics such that probability theta is the unknown parameter. Okay. So theta is unknown parameter. So theta is more than L, less than U. You may write equal. So let's not take this. So theta is more than L, less than U. This probability is we call 1 minus alpha. Okay. So we need to search that L and that U. Okay, we have to find. So confidence interval we want to find now. So we have to find the interval. So we want to find that interval L comma U. This interval we want to find such that probability of theta more than L less than U is 1 minus alpha. So then we call, okay, so U and L we have to search such that probability of theta more than L less than U is 1 minus alpha. So where alpha will be more than 0 less than 1. Okay. Then we call then we call this L comma U, this interval. Okay. So we call the interval. So interval you know from mathematics. Okay. So this is interval LU. For example, 1 to 2. There are many numbers like that. So if we take interval LU, so that interval is called 101 minus alpha percent confidence interval for the parameter theta. And actually we usually try to find the symmetric and like not always symmetric, but actually we want to find the smallest interval. We try to find, with that probability. So the 101 minus alpha percent. For example, suppose they will ask you to find 95% confidence interval for mu, okay, in a sample from normal 0 1. Okay, so yeah, normal, sorry, mu sigma square. Okay, where sigma square is known. Just I'm giving you example. So how you will use this thing. So they will ask you find 95% confidence. Ci means confidence interval for mu in a sample from normal mu sigma square where sigma square is known. Sigma square is known. So you may put some specific value of sigma square. They may give you like 1, suppose. So okay. So in that case, what you need to find? So you need to find some statistics L and some statistics U, such that probability that, so the probability that mu will be, okay, I'm explaining this thing. So mu will be more than L, less than U, and that probability is 95%. That probability is 95%. So 95%, like this. Okay, so but after reading question, don't be confused like alpha is 95%. So don't think like that. Alpha is not 95% because we have defined in that way. Okay, so book also there is a reason like defining that way. Okay, so some standard are there. You may define for alpha, then you have to carry your own notation for long term. Okay, so book define in this way. That's why we are carrying that notations only. So this is actually alpha is not 95%. Again, I'm saying. So alpha is here 1 minus alpha is 95%. 95% means 0.05, 0.95. Okay, so this is fine. No? This you cannot write. So 1 minus alpha is 95%. Okay, so why do we write the right 100 1 minus alpha percent? Actually 100 1 minus alpha percent, if you open it, 100 1 minus alpha percent means upon 100, so it will cancel out. So that is just the value of 1 minus alpha, nothing else. Just they want to write in terms of percentage. For example, somewhere you have 0.10, so you may write it 10%. So that thing is there. Okay, so that's why book will write this 100 1 minus alpha percent. That means the value of 1 minus alpha only. So this is just a definition, and we are again running out of time. So I have to take attendance also. So attendance sheet, I will not take on that. So I will just share you the link. You just fill it. So I'm sharing you a link in the chat. You just fill it within 5 minutes. This is the attendance sheet for today. So whenever they say that 1 minus 95% confidence interval means 1 minus alpha is 95%, 0.95. Okay. And as I said, alpha is between 0 and 1. So 1 minus alpha will also be between 0 and 1. And alpha will also be between 0 and 1. In that case, you will find alpha, so it will be 0.05. Okay. So when they will say you find 95% confidence interval. So alpha in that case is 0.05. And 0.95, 95% is 1 minus alpha. So sometimes the student get confused here. So just we are introducing this topic. In the book, it is not in detail. So I'm teaching only that. Okay, so you just fill the attendance. And for example, I may write one answer, but I will not prove. Just I can write one question. So example I'm writing. I will not give you the proof, but you may write like uh, 101 minus alpha percent confidence interval for mu in sample from normal mu sigma square, where sigma square is known. Okay, so I said you already, so you need to find that L and the u such that this is 1 minus alpha, right? So if you find that, so when we'll prove, or in the next class we'll do, so that will be like, so that will come x bar minus sigma upon root 10 z alpha by 2, and x bar plus sigma upon root 10 z alpha by 2. So you might be wondering what is this z alpha by 2, so that you will know next class. Or if you want to know, so I will just inform you that this is a distribution of a standard normal, suppose. So here is the mean is 0 in standard normal, I'm telling. Okay, so suppose this number is z alpha by 2, so the probability after that, or area under this curve, is alpha by 2, and here is 1 minus alpha by 2. So that number, what is that number? I'm telling you, what is that z alpha by 2? Z alpha by 2 is a number where capital Z is more than z alpha by 2. This is alpha by 2. So just I'm telling you this notation. What is the meaning of this notation? This is a number. You may tell it's a constant k. So this is a constant k such that capital Z more than k. So the probability will become alpha by 2. So that is the meaning of that Z alpha by 2. And what is confidence interval in that case? So it is like x bar minus sigma upon root 10 to x bar. So this is a L and this is a U. Okay, so this is the interval for mu. Okay, with confidence coefficient, you can say 1 minus alpha. With confidence coefficient 1 minus alpha, that is 100 minus 100 1 minus alpha percent. Okay, so let me check how many of you filled this. So in class, usually people just start attending by 40, yeah, 40, 45. At the end, you are 61. So you are not cared one. So don't care about taking knowledge, because you know already, you all are very brilliant, very good. And now it is 61 here. This lecture is being recorded. So if you want, we can trace who joined just now, because it is being recorded. Okay, thank you everyone. So we'll see later on.
Thank you, sir.